T-test then ANOVA single factor. So this is the complex formulas which is involved to calculate this one. The formula for calculating F statistic is you have to calculate sum squares within, sum square between, then degrees of freedom, mean squares within, mean square between, and then you calculate the F. So it's not as simple as a t-test formula. Whereas if you look at our t-test formula, it's a very simple formula. Whereas ANOVA single factor involves multiple formulas. And this is the F is this value. Once you compute all of values, you'll get the F statistic. Based on the F statistics and the degrees of freedom, we will decide the P value. So this is the ANOVA single factor. So one variable numerical and the other variable categorical, exactly two levels, t-test. Two sample independent t-test. Exactly two levels in categorical variable, two sample independent t-test. If there are more than two levels in categorical variable, ANOVA single factor or one-way ANOVA. So those are the two tests which we have performed in the previous session. Okay. Now let's go ahead and perform one of the other important hypothesis tests where both variables are non-numerical. You can open the last class notebook and run all the cells. Non-numerical and categorical. We conduct a test called chi-square test of independence. Chi-square test of independence is conducted when both variables are non-numerical. The null hypothesis, the input of chi-square test is cross tabulation. The input of chi-square test is cross tabulation. Cross tabulation is frequency table two non-numeric categorical variables. Two non-numeric categorical variables, we call it as cross tabulation. So chi-square test is conducted when both the variables are non-numerical in nature. The null hypothesis is there is no association between both variables. Alternate hypothesis is copy the same statement down and remove the word no. There is association between both variables. No association between both variables is your null hypothesis. Association between both variables is the alternate hypothesis. Hello. वो थर्ड फ्लोर रिसेप्शन में दे दो. So when your both variables are non-numerical in nature, we use chi-square test of independence. The null hypothesis is there is no association between both variables. Alternate is there is association between both variables, and we will use the same p-value less than or greater than 0.05. Test null no association between holiday and season. Test null, no association between holiday and season. So we have to first do cross tabulation. PD dot cross tab, bicycle share dot holiday, comma, bicycle share dot season. We got the cross tabulation. Okay. From SciPy dot stats import chi2 underscore contingency. Chi2 underscore contingency is the function for chi-square test. Chi2 underscore contingency, and then you can copy paste the above statement. Control C, Control V. The second value is the p-value. We fail to reject null. That means there is no relationship between both the variables. There is no relationship between both the variables. The second output, you type in Google chi2 underscore contingency, you'll get the function documentation. In that, you can see what arguments you have to give and what you will get in written as the output. So if you can go to the Google chi2 underscore contingency, the function first link scipy.stats. So here it says for the hypothesis test of independent of the observed and in the observed frequency is the contingency table and observed table. Or I think there should be easy hypothesis in between somewhere. So if you look at this test documentation, this is what is happening. It gives you the test statistic, it gives the p-value, it gives the degrees of freedom, and it gives you the expected table. I will show you what is this expected table. From the observed table or from the actual table, an expected table will be created using the formula row total multiplied by column total divided by grand total. If expected table will be calculated, and the formula is sigma observed minus expected whole square divided by expected will give you this chi statistic. From chi statistic, you calculate the p-value. From, sorry, for p-value, you have to have chi-statistic and degrees of freedom. Degrees of freedom and chi-square statistic you have, you can calculate the p-value. I will show it in Excel once we are done with it. So if you look at the output is giving us all those things. So this is the chi-statistic. This is the chi-statistic. This is the p-value. This is the degrees of freedom. The formula for degrees of freedom is number of rows minus 1 multiplied by number of columns minus 1. R minus 1 into C minus 1. So if you look at how many columns we have? 4 columns. 3. 4 minus 1 is 3. 2 minus 1 is 1. So the degrees of freedom is 3. And this is the expected table which is created from the original table using the formula row total multiplied by column total divided by grand total. So the formula is this. Chi-square test of independence. Okay, observed minus expected whole square divided by expected sigma x square. This is the formula for chi-square test of independence. Now calculate test null, no association between working day and weather sit. Working day and weather sit. Test null, there is no association between working day and weather sit. PD dot crosstab bicycle shade dot working day comma bicycle shade dot weather sit. Got the cross stabilizer. Now use the formula chi2 underscore contingency. Hello. Definitely. Yes. ఇప్పుడు కూడా అదే ఉంటుంది కదా ఆర్గనైజేషన్ పేరు తగ్గలేదు chi2 underscore contingency, copy paste it, pd dot crosstab. So p value is greater than 0.05. Fail to reject null. Fail to reject null. So this is chi-square test, which is conducted on both non-numeric categorical variables. If both the variables are non-numeric and categorical, we conduct chi-square test of independence. Okay. All right. Now, sometimes you will have data in the form of before and after. Data comes from same entity, but at two different time intervals. Like before and after an event. Before and after an event. Take, for example, the blood pressure of the patient before taking the tablet, the blood pressure of the same patient after taking the tablet. You have this data in the form of before and after. There, we use something called paired sample t-test. Paired sample t-test is used when your data is in the form of before and after. Paired sample t-test. Take, for example, we have demonetization, right? Before demonetization, 2016, November, we had demonetization, right? Before demonetization, the CPI, Consumer Price Inflation of India, was 3.35, 4.14, 5.30, 6.46, 6.13, 6.59, 5.86, 5.51, 5.53, 5.91. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have only 10 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need two more. December is 6.32 and 6.70. This is 12 months. After demonetization, after demon is equal to After demonetization, 2.59, 2.23, then 2017, January. 1.86, 2.62, 2.61, 2.21, 1.09, 1.08, 1.79, 2.52, then 2.89 and 3.24. So I'm pasting the data before and after demand. CPI, consumer price inflation. I've sent it in your mail, just check your mail. So this is the 12 months before and after. 12 months before and 12 months after. Print NP dot mean before demon. Print NP dot mean after demon. So before demonetization, the average is 5.65. After demon, the null is there is no significant difference in average CPI, consumer price inflation, before and after demonetization. Same statement, you can copy down, change the null to alternate and remove the word no. There is significant difference before and after demonetization. NumPy, what did you give in top? NumPy as NP. Just check. There might be some mistake there. PO? You have given it as P? PY, yeah? Then it have to be PY by dot mean. PY by dot mean. Whatever short name you gave to NumPy. Go to scipy.stats and check for control F and see the paid sample t-test. What is the function? In the scipy.stats, control F, paid sample. You type paid, you will get the function name. Scipy.stats. If you go to scipy.stats page, scipy.stats. The statistical functions, control F, paid. Paid is not there. Huh? Ah, okay, it is called as related sample. See here, two related samples, A and B. It is here, it is called as related sample. Related sample t-test. Paid sample or related sample are all same because one person or one entity gives you or one event gives you two samples. Before an event, after an event. In sales and marketing, we use digital marketing. Before Facebook campaign, after Facebook campaign. What was the change in sales? Okay, so t-test underscore rel is the function. From scipy.stats import t-test underscore rel related. T-test underscore related, open bracket, before daemon, comma, after daemon. Since p-value is less than 0.05, what we will do? We will reject the null. That means the difference in means is statistically significant. The difference in means is statistically significant. Okay. Similarly, GST. We had GST also, right? July 2017. What is the effect of GST on the inflation before and after? Yeah. So this is the data for before and after GST, 12 months. Same consumer price inflation. I've sent you the email. You can take it from there. Here I'll paste it. Before GST and after GST. Print np dot mean before GST. Print np dot mean after GST. So the means are different. The means are different. Conduct the hypothesis test and tell me whether it is reject null or not. Failed to reject null. You have already imported the function, just run the test. So p-value is less or greater? P-test underscore rel before GST, comma, after GST. P-value is greater than, so there is no difference in means. We fail to reject null. And the formula is this. This is the formula. Sigma d divided by n into sigma d square minus sigma d whole square divided by n minus 1. D is the difference between before and after. Okay. Now, as a practice to what we have done, let us do it on a different data set. Then we will go into Excel calculations. Okay. Analytics Vidya, HR analytics. There is a practice problem on Analytics Vidya, HR analytics, data hack, Analytics Vidya hackathon. It's a practice problem. Just register it using your Gmail ID. And in problem statement, you will get the data, train file, test file, and sample submission file. You'll get the train file, test file, and sample submission file for Analytics Vidya HR Analytics Challenge. Analytics Vidya HR Analytics Challenge. Just use your Gmail ID to register. And download all the 3 files and save them into a folder called HR Analytics. There will be 3 files in the bottom in problem statement, train file, test file, and sample submission file. In the last, you will see the files, train, test, and sample submission in the problem statement. See, problem statement is the register, you have the register. Then you go to problem statement. Once you register, you will get this page looking like this. Yeah, it's a hackathon. It's a data hackathon. No. HR Analytics, you have to click on HR Analytics challenge. Did you click on HR Analytics? See, go to your Analytics Vidya and you can find it in directly type Analytics Vidya HR Analytics. You will get the link. Or you go to Analytics Vidya. In Analytics Vidya, you will go to hackathons. Within hackathons, you will see HR Analytics. It active, the third one. Click on participate. Once you click on participate, you will get the register option. Register using a Gmail. Then go to problem statement. Once you click on problem statement, if you scroll to the end, you will see the three files: train file, test file, and sample submission files. All three files you download and save it into a folder. And you can see the variable descriptions also very clearly given. Problem statement. You have to go to problem statement, scroll to the end, you will see three files. All three files you download. Open a new Jupyter notebook, import the file, and run these steps. Only train file is import. Only train file, only train file. Done? No. Uh, Test null, first you do the group by between average training score and promoted 0 and 1. You have done, right? Then you have to split the data into promoted 0 and promoted 1. Promoted 0 means no. 0 means no, 1 means yes. You have to split the data frame into promoted no and promoted yes. Then you take the t-test of relevant values. Which one? Yeah, I'll do it. Import matplotlib dot pyplot as plt percentage matplotlib inline import io percentage cd quotes data is in hackathon HR analytics folder info on HR analytics. Okay, then HR train is equal to pd dot read underscore csv double quotes hackathon folder HR analytics data info file name dot csv, right? Then HR train dot head. HR train dot train. Chart train dot shape. 54,808 rows, 14 variables. HR train dot d types. Integer, object, and float. HR train dot columns, variable names for your reference. HR train dot describe. Describe will only take the numerical variables. It will ignore the non-numeric variables automatically. Okay. Then HR train dot average training score dot plot time is equal to fixed. So what do you observe here? I think there are two peaks. Left positive skewness, two peaks might be there, or more, maybe three peaks. HR train dot average training score dot plot time is equal to box, comma, what is equal to box. So there are no outliers, but the box is skewed towards the left, not towards the left. It is more towards the right. Why we are getting out? HR train dot average training score dot plot time is equal to density. See, we have multi-peaks, multiple peak mode, not normal distribution. Then this one, test null. So the process of hypothesis testing is, first you need to do group by. To check the group by with mean, right? You have to check the mean variance, mean difference. Then you also have to do group by with variance also, to check the difference in variance. Then you will do the null and alternate hypothesis. Then we will split the data, split data into two levels. Then conduct the test. And then the interpretation. Infer p-value. So this is the process. First group by mean, group by variance, then null and alternate, and then split the data into two. And then we'll infer. So HR train dot average training score dot group by HR train dot is promoted dot mean 62.64 and 71.32. Mean is different. Then variance is also different. Mean is different, variance is also different. Both mean different and variance different. So you have to check both mean and variance because we have that equal underscore var is equal to false argument. So for that, we need to check. Null. There is no significant difference in average AVG underscore training underscore score of is underscore promoted 0 and 1. Same statement, control C. Control V. Change the null to alternate, remove the word no before the statement, okay? So first mean difference, variance difference, then null and alternate. Now we have to split data. Promoted no is equal to HR train square bracket HR train dot is underscore promoted double equals to 0. Promoted yes is equal to HR train square bracket HR train dot is underscore promoted double equals to 1. So we have to split the data based on the criteria. Hello. Hello. No, not required. Then import the function from scipy dot stats import pretest underscore int. Then connect the test. Promoted no dot average training score, comma, promoted yes dot average training score from equal var is equal to false. And then we'll get the p-value. We will reject null. So we are splitting on the criteria. All the zeros will be in one data frame. All ones will be in one data frame. So we are splitting the data into two. So print promoted no dot shape print promoted s dot. So we have split our data frame into two. One data frame with 50,140 rows, the other data frame is with 4,668 rows. That means there are 50,140 zeros in our data in that particular column and 4,668 ones in that particular column. So we are splitting the data on the criteria, all the zeros in one data frame, all one is promoted, zero in one data frame is promoted one as other data. We are just splitting this table into two split with the criteria that is underscore promoted should all be zero. Only one column, no? See, this is the one. No problem. Promoted as dot head. Okay. Now, if I go to the dependent variable, see all are ones. There are no zeros. All the values in this cell will be ones only. Similarly, the other data frame promoted no dot head. If you go and see, all the values in that cell will be zeros. All zeros in one place, all ones in one place, two data frames, subsetting the data frame into two. Based on the criteria, is underscore promoted zero, is underscore promoted one. Because we need to split it like that. Got it? Now do the next one, same thing. The next one between recruitment channel. So test null, the same process, but here we don't need to calculate where. Here we don't need to do, everything is same, but the only thing is we don't need to calculate variance. Variance is not required here. You just need to calculate mean. See, split data into n levels. How many levels? We don't know. T and E. Here we don't need to, we will only know the levels after doing the group by. So once you have done the group by, you will know how many levels. So how many levels are there? dot v. So there are 4 levels are there. No, 3 levels are there. 3 are there. Other, referred and sourcing. So more than 2. More than 2 means another single factor. Now we have to split the data into 3 data frames, where one data frame has recruitment channel, all other, only other values, referred values and sourcing values. Okay. So other is equal to HR string, data frame name, then the variable name, double equals to single or double quotes. You can copy the name from here. It should exactly match. If it mismatches, it's a problem. Then you can copy this down, Control C, Control V, and then change the to refer and change the value to referred. Then paste it again. Sorry. Control C, Control V, we'll call it as source. Then we will take it the value from here, sourcing. So we are splitting the data frame into 3 sub data frames: other, refer, and source. So the null hypothesis is there is no significant difference in average length of service of different types of recruitment channel. Copy the same statement down, Control C, Control V, change the null to alternate and remove the word no before significant. There is significant difference. From SciPy dot stats import f underscore 100. And now you can conduct the test. Got it? So reject or fail to reject? Anyway. Other dot length of service, comma, prefer dot length of service from source dot length of service. P value is less than 0.05. So we will reject null. Okay, do the last one. Chi-square test. Gender and recruitment channel. What happened? You got NaN, huh? NaN means you have over checked the subsettings. You might have done the same thing again and again. You have to re-import the data and do it. Once you correct the error here, and then you have to run all the cells. See, first correct here, what mistake you have done. Okay, then go to run and run all the cells because the data will also get corrected. First find the mistake, where you have done the mistake, then correct it, then run all and run all the cells. Then only it will work. So, got it? So that you have to be careful when you're subsetting the data. The last one, chi-square test of independence. So PD dot raster HR train dot gender, comma HR train dot recruitment channel. Got a cross tabulation of gender and recruitment channel. Then the null. The null hypothesis is no association between both variables. Alternate would be association between both variables. Use the tab function, autofill. That way it will be faster and you will eliminate mistakes also. From SciPy dot stats import CHI and then tab to give you the chance. Try to contingency. Try to contingency, open bracket, then PD cross tab. So p value is slightly, failed reject null. Above 0.05 to reject null. That means there is no relationship between gender and recruitment channel. We are accepting. Fail to reject means accept. Fail to reject means accept. All right. All of you got this? Now, open that day.csv file which you have, convert it into an Excel workbook. You have the day.csv file, right? Open the CSV file. File, save as, choose the location, and then file format, change it to Excel workbook, first option. Save as type, change to XLX workbook, the first option. Save as XLS workbook, okay? Because in CSV, we can't save the outputs. So, file, save as, choose a location, and then format, save as type. Below save as, you have the save as type, na? Choose it and choose the first option, XLX workbook. Now, all of you go to data tab and check, do you have data analysis tool pack? Data tab, data analysis tool pack. Go to the data tab. Right extreme corner, you don't have? Okay, no problem. File, click on file. Options. Scroll down, you will see options. options, you'll see addings. File, options, Excel options or options. Addings will be there, right? In addings, bottom you will see manage Excel addings go. Click on that go. Manage Excel addings go. Oh, yeah, first open the Excel sheet file. You have to click on the window side. Excel options. Addings. Manage Excel addings go. Take my question and I'll put it back and follow them. First and the last. Now it is just it's an inbuilt item. They also. So it's for data. Now go to the data tab. It's installed all of it. Once it's installed, it will show you data data tab, data analysis. Now in data analysis, you can see all the functions available: ANOVA, single factor, covariance, correlation, descriptive statistics, the t-test, all of them. Okay. Now what we will do is we have done what holiday and CNT, right? So go to home tab, sort and filter. Home tab, sort and filter, apply filter. Sort and filter, apply filter on the headers. Sort and filter, apply filter. Now, first sheet only, not day. Okay. Once you put the filter, unselect all, select only 0. Now you can see all holiday 0 are there, right? Now you go to the CNT column, Control Shift down arrow, Control C, Control V. This will be holiday underscore 0 underscore CNT. Right? Apply a filter. So first step is apply a filter on holiday and tick mark 0, unselect all, tick mark 0. Then select the column of CNT. Go to right side, CNT is there, na? Control Shift down arrow, select all the cells. And then paste it in the next sheet. And with CNT you copy and paste it and add holiday underscore 0 to it so that you will know that is holiday underscore 0 data. Okay. Now unselect 0, click on 1. And then you will see 1 data. Now go to the CNT column, Control C, go to sheet 1, Control V, holiday underscore 1 underscore CNT. So we have, this is what we were doing, subsetting the data. Now you understood what we were doing in Python? We are splitting the data means we are doing like this. We are separating the 0 value counts into 1 value counts into other. See here, 0 and 1. Got it, all of you? Now, Control C, put it here. What all we need for calculating the t-test value? We need mean, we need count. Count or n. We need average. We need variance. We need count. We need average. We need variance. All of you got the data like this? Now, just calculate the mean, count and variance. So, is equal to COUNT, count, open bracket, select the first cell, Control Shift down arrow, close bracket, enter. 710 observations are there in 0 is equal to average. First cell of number, Control Shift down arrow, shift close bracket, enter. Average is 4527. Is equal to var, open bracket, first cell, Control Shift down arrow, shift close bracket, press enter. Shift close bracket and press enter. Is equal to count. This is the data reference. You can see here the formula. Or you can type also. Is equal to count A2 colon A711. You can type. Small letters also you can type. No issues at all. Average is equal to average. Variance is equal to var, VAR. So the means are why we are doing is to check the mean difference and variance difference. We need to check the mean difference and variance difference before we run the test. Select all the 3 cells, formulated cells, drag. It will calculate for the B column also. VAR. Dot P is population, dot S is sample. The denominator is n and n minus 1. That is the only difference. Population is n, sample is n minus 1. Okay, the mean are different, variance is also different. Okay. Now go to the data tab. Data analysis. If you scroll down to the last, you will see there are 2 tests. T-test, 2 sample assuming equal variances. T-test, 2 sample assuming unequal variances. Which one we should use? Unequal variances, because there are 2 t-tests, assuming equal variances, assuming unequal variances. Are our variances equal? No, our variances are not equal. So click on that unequal variances, click OK. Now you see here variable 1 range, click on the box next to variable 1 range, go to the header, Control Shift down arrow, click on the box again, color box again, variable 2 range, go to the header, select the ranges of variable 1 and variable 2. Variable 1 is column A, variable 2 is column B. A1 to A711 is variable 1 range, B1 to B22 is variable B range. We have selected the labels also. Tick mark, labels means headers. Tick marks labels, because we have selected the headers also. Tick mark the labels. Alpha 0.05 means 95% confidence level. Let it be alpha 0.05 because 95% confidence level. Output range, click on output range, click on the box and select some empty cells. Output range, click on the box and select some empty cells. Some 3-4 empty cells you select. And click on OK. Click on OK. So you can see here, A variable 1 is the A variable range, variable 2 is the B variable range. Since we have selected the headers, tick mark labels, let alpha be 0.05, output range, click on the box, select some empty cells and click OK. You will get the output, right? Now, what is the here? We have to look at p value two-tailed. Two-tailed p value. Two-tailed means rejection on both ends. The rejection on both the ends. Two-tailed p value. 10300, right? Now, if you go to Python, we might also got the same one. Exactly same thing might be the answer which we would have got for the t-test between holiday and see 1030 round off. Exactly the same value, p value. And statistic is minus 17046. You can see in the Excel sheet, you got the same value. The t statistic here 1704686. See the t stat. You got the same value, right? And the p value is also same, exactly same p value. So what is our interpretation here? Since p value is greater than 0.05, we fail to reject the null hypothesis. That means the difference in means is not significant. The difference in means is not significant. Got it? Same, you will get the same answer. To the decimal, you will get the same answer. Now, you want to do the manual formula, you can do that. What is the formula? See, this is the formula, right? I'm pasting it in Excel for your reference. Oh, very large. So this is the formula. Okay. So is equal to open bracket mean 1 minus mean 2 close bracket. This is the numerator. Mean 1 minus mean 2 divided by square root of open 2 brackets variance 1 divided by n1 close bracket plus open bracket variance 2 divided by n2 close bracket. You get the same 1.704686. Got it? Now, for the p value is equal to t dist. Oh, we have to calculate degrees of freedom. Degrees of freedom n1 plus n2 by 2. n1 plus N2 minus 2, right? So 731 minus 2 is 730. Degrees of freedom is 730. So is equal to T dist X, sorry, T dist X, comma, degrees of freedom. Oh, we want to give one more, huh? Acha, two tail. So we got 0.08, huh? How come we got 0.08? No. Okay. Is equal to T dot dist 2T X, sorry, E dot dist dot 2T X, comma, degrees of freedom. So you have to use P inverse, huh? No, P value. Actually, we use T dist only. Why it is not working? That is to conduct the T test directly. Okay, we are getting 0.08 P value. So the actual value is 0.10. I don't know, there is a difference in P value calculation here. Why there is a difference? You're also getting the same thing, 0.08? Sorry. I think the degrees of freedom value only it is changing. It is using a formulated degrees of freedom value. But anyway, this is the formula for finding the T statistic. Here. This is the formula for finding the T statistic. Mean 1 minus mean 2 divided by square root of variance 1 by N1 plus variance 2 by N2. So follow the color coding. You can see the brackets and color coding is important here. DF1 and DF2. So DF1 is N minus K. That is your number of observation minus number of variables. Minus number of variables. The other one is you can check in that fixed things. All right, forgot DF1. One second, I put it there in that shift notebook. Share. Yeah, K minus 1. First is K minus 1, number of variables minus 1. First D of 1 is K minus 1. Number of K is number of variables. number of variables minus one. The second one is n minus k, number of observations minus number of variables. K is number of variables, n is number of observations. So df1 is k minus 1, df2 is n minus k. So there will be 2 degrees of freedom for ANOVA. You got the formula for the t statistic? If you didn't get the formula, you can do with you got this output, right? Function of it. This formula, check the brackets. You have to check the brackets. The brackets are very important here. How you position the brackets, they are very important. Which one? What p-value you give? 0.13.
So the 1.7 is the t statistic, comma 1, comma. This is 729.
729. Okay. Okay, 731 minus 2. Yes, 729. Two tails only, right? Here isn't TDS 2T or TDS 2.
TDS 2. Next, comma 1. 2 degrees of
No, F is different. F is different. But F is a different distribution, ANOVA. Actually, this is also based, see, there is a complex formula for degrees of freedom. This is based on that only, but both of them are reject null, right? Sorry, failed reject null. Both of them are failed reject null. Actually, there is a complex formula for degrees of freedom calculation, which Excel uses. We might get some alter, but it is again failed reject null, even it is failed. Two sample independent t-test. Got it right? Formula is for your understanding, manual calculation, but you can use the data analysis tool pack directly. Okay, so once it's 4 o'clock, we'll take a break. Yeah, and then after break, we'll continue.